This new chapter we are starting is going to be all about exponential functions, which, for your warm-up, you guys just did an example of an exponential function. So that is this table right here. And we're actually going to graph this so you can see what it looks like. And then we'll talk about it. And it's not going to be super intense today. We'll get a little more intense later, but not too bad right now.
A new derivative
Yeah.
function.
So the I think I actually meant to delete this and then just paste in one in. That's good. All right. So we are going to graph our warm-up problem here. Where are you? There we go. So we are going to graph this warm-up problem here, just to see what an exponential function looks like. So I'm going to graph it real quick. I have negative 2.25, which is about right there. I have negative 1.5, which is right there. 0, 1, 1, 2, and 2, 4. So this, and make sure you guys are following along because these are with notes, or these are for your notebook checks. Yeah. So this is an exponential function. And exponential functions have this kind of one characteristic. They start off really, really flat, and then they will all of a sudden jump way up or jump way down. This could be flipped around and it could be going down like this all of a sudden. That would also be exponential. So that's how exponential functions look. They start off flat, and then they go way up or they jump way down. Or sometimes they're flipped around the other way. Sometimes they're like huge jump and then level off, or they raise up really quick and then level off. So they'll look like one of these four situations. It just depends on the equation. And we're going to look through and work with a few exponential functions. We'll learn a little bit of vocab stuff today. You can hang on that for a game? Yeah. It's probably good call. Thanks, man. God, didn't even say it. Too quick. Alright. No, so we're going to look at this next exponential, or these two exponential functions here. So there are two kinds of exponential functions.
Alright.
This the blue one, start with this one, is exponential growth because it starts out flat and then it starts getting bigger. So that's exponential growth. Or in other words, as you go to the right, your graph gets bigger. So when you look at these, you pretty much always go from left to right. As you go from left to right, it gets bigger.
Oh, you think so? Would it be
Close. The red one is called exponential decay. As you go from left to right, it gets smaller. So this graph actually never stops getting smaller. It just goes really, really slowly after a while. So it's always going down, but over here it's like barely changing.
Simple.
And then exponential functions also have what is called an asymptote. It's a fun word. So in these two, we probably a little bit. In these two exponential functions, the x-axis is an asymptote. So that changes around. So an asymptote is an invisible line that your graph will get really, really, really close to, but it never crosses. So this exponential decay function right here is going down, right? But it will never actually go down and cross this x-axis like this. It'll just keep getting really, really, really close to the x-axis. But it never crosses. So it's like an invisible line your graph will never cross.
Or will it?
It won't. I promise it won't. So that is what exponential graphs look like. And most of what we're doing today is just working with some exponential functions. So this is a basic exponential function. So it's f of x equals ab to the x, where a and b are both numbers, just both regular numbers. So if a is greater than 0, and if b is a decimal, we have exponential decay. And when I say decimal on here, when I say decimal, I mean between 0 and 1. I could have a 1.5, and even though that has a decimal in it, it's not decay because it's bigger than 1. So if it's a decimal between 0 and 1, we have decay. And if it's not a decimal between 0 and 1, we have growth.
Never would guess.
So without ever actually graphing these like we did on our warm-up, we can say, is it growth or is it decay? by looking at the, so the thing with the exponent. So on this first one right here, I have 5 to the x. That is not a decimal between 0 and 1, so that one's growth. This one's a decimal, 0.25, so it's decay. And this other one is bigger than, or the first one is a decimal, but we're looking at the one with the exponent. And that is going to be growth, because it's not between 0 and 1.
This should be our lesson.
The number in front will actually determine if it's flipped up like this or if it's
Oh my god.
like flipped around the other way. That's what that number in front does.
Story problems.
How many lessons is in this chapter?
4 or 5.
That's it?
Yeah, this chapter's not very long.
Oh, thank God.
How come Miss Allen was saying we're having smarter balance in a week?
What?
Yeah, Miss Helen's trying to scare us, man, but I called her off.
She said math smarter
I
balance
guess
in a
she's
week.
claiming that there's a math coach next
Math smarter balance.
No, it's in May.
I told her.
That's what I
It's
said.
in May.
Yeah,
And she
it'll
was
be
like,
like the
"Oh."
first or second week of May. I don't remember exactly off the top of my head.
Well, except the
What did you
first.
actually do
Alright,
next week?
So we are going to be
We're all
working with,
brother.
mostly today, we're going to be working with a specific exponential.
Calculus.
So this is going to be our
Thanks,
exponential
Alyssa.
growth or decay
Okay.
formula.
Excellent.
So there are 4 pieces in this formula. My formula is A of t equals lowercase a, parentheses 1 plus r to the t. So in these pieces, this A of t is my ending amount. So A of t is whatever I get after I calculate something. And what this is used for, we use it to calculate how much something is after a certain amount of time. Like for example, banks might use something similar to this. They won't use this one because it's not very complicated. But let's say, and you'll actually do some examples, if you deposit money in a bank account and it has like 2% interest, how much money do you have after 5 years? You can use this type of formula.
Not
Most banks are more complicated than this, but this is kind of a close approximation.
the other interests are stupid.
Alright, so this A of t is your ending amount. This little a right here is your starting amount. So whatever you start with, you put in for a. This r right here is our rate, and that is how much our growth or decay is. So r is our rate.
Oh.
I should probably say that. If it's positive, we have exponential growth, which means we're getting bigger. If it's negative, we're going to have exponential decay, which means we're getting smaller. Actually, it's not this way. It would be this way. And then the last one, the t, is the number of time periods, or just time.
Can you just put time?
You could just put time. And this formula we use pretty much always on real-world situations, which we're going to see in just a second.
Wow.
It's like I planned this.
Probably not. Just copied out of a book.
Story problems.
Yeah, these are good stuff though. Even though these are story problems, they're really not.
You invested 1,000 in second grade.
All right.
Sixth grade.
So let's say you invested
In sixth grade,
$1,000
$1,000.
in a savings account at the end of 6th grade. I don't know where a 6th grader got that much money. but
Exactly, dude.
No.
My parents are drug dealers.
The account pays 5% annual interest.
18.
How much money will be in the account after 6 years?
We do stuff like
So,
this in
we are going to use that formula we just had, which I'll write down again so I can see it. And that is A of t is going to equal A
At
1 plus r to the t. Okay.
1 plus n.
So my starting amount on this is 1,000. So I'm going to plug that in for A just a minute. My growth rate is how much I'm changing by. How much am I changing by on here?
5%.
5%. All right, and this can be a little sneaky sometimes. So this 5%, am I getting bigger or smaller?
is this in
We're getting bigger, right?
economics?
Yeah.
This is a positive 5%. All right, when we put these in though, we don't want to toss in a percent in here. I need to change this to a decimal.
Oh, what?
So to change it to a decimal, we take our, so if I were to write this out, this would be like a 5.0, right? To change this from percent to a decimal, you move your decimal left twice,
That's if I did it.
and every time you jump in an empty space, add a 0.
If so,
So this is
Sounds about right.
0.05.
that's the way I was taught.
So my R isn't 5% because I can't put a percent sign into here.
0.05.
So it is 0.05 because I converted 5% into a
Why
decimal.
do you go over twice?
So remember, to go from percent to decimal,
It's only 5.
move the decimal
It's
left
not
twice.
25%.
Well, you have to go twice
Mhm.
every time?
Yes.
Unless it's 50%.
Some people
Well, if it's
have
50%, then it'd be 50. 50.
Percent.
But it's
It
fine.
would be like a 1.1.
What about 114? Oh, no, 314.
I did this one.
More decimals after that.
Ah.
All right, and then the last thing,
Everyone's right.
we need our T, which is the amount of time and the time period. So, we want to know how much money is
I
paid
think it's
after
different,
6
actually. I
years.
don't know if that's right.
And this one can also be a little sneaky. If it's annual interest, how many times are you getting paid a year?
Once.
Once. We're getting paid once a year for 6 years, right? Which means we are getting paid 6 times. You gotta be careful because sometimes it might pay monthly.
Oh,
If it pays
yeah, 12
monthly
times.
over 6 years, yeah, it would be 12 times 6, which would be something different. So you gotta be careful and make sure your time periods are right. So it's not super tough to do, you just gotta make sure you gotta watch out for the
It's probably
speed.
writing this down.
Alright, so I have everything in here I need to calculate this formula. I'm gonna go A of T, it's gonna equal, my starting amount is 1,000. Now I'm gonna go 1 plus my rate is
Hey,
0.05.
put 18
Ooh, I wrote that right.
And to the T is 6. Oh yeah, that should be A of 6, I guess, right there. So A of T.
God damn it.
A of 6. Oh, I fixed it. Oh,
Oh God.
oh man, that's
Yeah, we get it, we get it, we get it. Uh-huh.
6. And Desmos is nice because we can plug this straight into Desmos. I just
Oh,
forgot to.
yeah,
So
forgot
it's
to-
8 of the
that
6
one,
tower?
I'm stupid.
No, it's not 8 of 6. You shush. Let me grab Desmos real quick. I forgot to get it.
77. 53.
2 times.
We need that also?
Yeah, you'll need Desmos.
45.
We don't need it.
You is.
Pencils,
You is
got
right.
pencils there?
Alright, so it is.
What?
We're gonna plug this straight into Desmos, so it'll be 1,000. And then 1.05. Oh, I guess I should do it like I did. 1 plus 0.05 to the 6 power. And
I was right.
you get decimals almost always on this, which is fine. Round it, on everything today, round it to the nearest hundredth.
Goalkeeper Henson already taught me how to do this.
Yeah, actually they use
Yeah,
something
do
very,
this
very
with-
similar
yeah,
to this in
economics.
banks. Yes.
Yeah.
So we'll actually, do you guys do the PERT formula? P-E-R-T?
I know they did it last year.
Yeah, so we'll learn that one too. So yes, this is very, very similar to bank stuff. That's why we'll do a lot of money story problems.
Can I use the calculator he lets us use?
Cookie.
Why?
Cookie.
What?
I know how to do it though.
Uh,
I already have this
What'd you
math
get?
lesson in economics, dude.
My
So.
pointer is 6.
Why did I get a message from you?
Can we have a short summary?
I don't know, I'll have to look at it here. Alright, so we plug this in, we got 1,340 and 9.09.
0.09.
So
that
A
one, what
of
do we
6 equals 1,340.09.
0.1.
But
Whoa.
this is a story problem, right? What are my units?
Dollars.
Dollars. So we gotta be careful. On all of our stuff today, we will have units pretty much in all these story problems. So you make sure you answer with whatever
You don't
you're
want us
talking
to
about. So
answer-
we're talking about money on this one, so we're gonna answer with units of money.
You don't want to answer using the question, so this kid will have.
No.
Shut up, Austin, right now.
Unless you want to, I don't mind.
It will prepare us for the
Just
future.
for you, Austin.
That's fine. I'd rather write.
What?
Alright, so we'll do another one here real
Story
quick.
problem
I'm just
answer.
gonna check Kala's.
Never mind.
We
I
should
answer
The kid has this much.
No.
Amount in 6 years that he saved in interest.
Where's the answer?
Yeah.
Dollars?
Alright, let's do this next one real quick.
Dude, this is easy knowing.
So,
this.
suppose you invest $500 in a savings account that pays 3.5% annual interest. How much will be in the account after 5 years?
I should be able to use
So
my
on this, we
resources.
just need to go through. Our starting amount is 500. Our rate is 3.5%, right?
Yeah.
But we need to change that into a decimal. So I got to move my decimal left
0.
twice.
0.35.
0.035. So my decimal for my R
Me too.
0.035. And then the last one, the
If I
amount
could
of
just use a
time.
calculator, I'd be fine.
For the amount of time here, we need to be careful that it's not being sneaky. Since it's annual interest, that's once a year. Once a year for 5 years is just 5. So we have everything we need to calculate this. So we're going to go A of 5 is going to equal, let's see, we started with 500, and then it'll be 1 plus 0.035 to 5. And you just go plug that straight into decimals.
I have
Which
a
is that?
question.
You plug it in, Dazen?
So
I have a question about the decimal.
Yeah. What about it?
Why is there a 0?
Never mind.
Because, so you move the decimal left twice, right?
Why is it on the left side? That was on the right side.
That would be 35%.
Yeah.
Or 300,
Isn't it 35%?
that'd be 350%
Oh.
actually.
3.5% here, right?
Oh, 3.5.
Yeah.
It'd be 350%.
That was 35%.
That would be a nice.
That would be a lot of
That'd
money.
be
That'd
nice.
be a good bank. You should
That
invest
would
in
be
that
great.
bank.
It's 350 in interest. That would be nice.
Yeah.
I just didn't see the point.
You earn $1 if I did this right.
All right. Do you plug that in, Dazen?
Yeah.
As we were talking, what'd you get? Trust you.
Oh,
He's not done.
did I do? Oh, I didn't put the exponent.
I got it.
593.84.
593.84. And we need to make sure dollars. You make sure you're using dollars. All right.
That's not a dollar sign, that's a percent sign.
593.84%.
A percent increase.
All right. You guys are gonna do this next one,
That's
but
like a
we are just gonna
50%
make
increase, that's
sure
terrible.
that we get it set up right first.
Uh-oh.
Actually, no. You guys can just do this one.
Which one?
Oh,
We'll do the top one.
You're gonna get a decent amount with that one.
Yeah. This one is probably a little unrealistic. This
No,
bottom
that's-
one is more realistic.
That's pretty realistic because it's about 10% annually per year for interest right now.
What are you on top or bottom?
So if
Top
you
one.
got 10 years,
so would it be point
12,000. That's
zero
gonna be a
eight
decent
or
amount.
0.008?
0.08.
Okay.
All right.
said neither of the above what she just said.
So I want you to do this one on your own. So tell you what. No, you guys can do this one. I believe in you. If you're a little confused on the decimal for R, let me know and I'll help you out and double check yours.
25,000. It's about double.
Not bad for doing nothing.
Almost 26,000, but
Hey, it's for amount.
If I was a young meerkat.
1.1.
It's from,
See, I like doing this stuff.
From,
Holy crap, this is fun.
what's that?
Way
The
nicer.
Lion King.
Because I've already done this
It's not from
too.
the Lion King.
Yeah,
is my
Lion
interest.
King, like 1.5 or something.
I like
Stupid
It's like
fun.
just about
No,
Timon and Pumbaa.
This is in my interest.
Or
Stupid.
missing
Stupid.
If I was a young meerkat.
If you guys finish the first one
You get
quick,
some
do the
my
second one.
interest.
You're gonna do them both. Second one's a little sneakier though.
Yeah.
Oh, we're doing the second one?
Mhm.
Second one?
You're gonna do them both. If you finish the first one real quick, do the second
See,
one.
monthly interest.
30 years, that's
But it's monthly.
Keep going.
Monthly interest.
And don't forget the formula
So
is the one
it's not.
plus
You
R.
30 times is 12
So the
times
one
30.
plus.
I was gonna do that below. I was just putting it for reference. That's why I didn't even do it. So I don't have to work.
It'll be the exponent at the very end. It'll be that one.
See, so now I just do this. That's not what I was meant to do.
What I was meant to do.
Mm.
No, but this is-
Oh no!
That's my Chromebook.
I thought you fell over here, dude. My heart dropped.
Yep.
I thought you hit every time. Oh! I like that was just.
It's
How'd
fine.
you do that?
The second one is
You follow.
really
What were you
unrealistic.
actually doing?
I was trying to grab it.
You got the bar.
This kid.
8 million? Is that 8 million?
Plus 2, 0, 2, 5.
87 million. Dang. Yeah.
Yeah.
No? What are you talking about?
I can't believe that just happened. I'm so
Where'd you get
sorry.
that?
There's no way
Jaden?
possible since 0.75.
Dude, no.
I missed. That's hard to read because there's no gaps.
Monthly interest rate.
87, 0,
That's a big number.
0, 8, 0, 4.
Wait, what times it by 12?
Oh my god, I think I did
Yeah,
this
it's
wrong.
87 million. That's only
0.09.
0.1, but
The
Why
second
you
one's
say
a
around
little sneaky.
700?
no,
No.
no, no.
Yeah.
Then that wouldn't be 0.09, that would be 0.1.
I know, but he's not seven.
Yeah, but it'd still be 0.10 because the 5 is a
Yeah.
Yeah, but it's better to put
That goes a 6, 6 goes a 9, which makes it 10.
No, no.
Probably not.
Believe yourself. Except for dropping my Chromebook.
I got it. I know, I'm sorry. As an accident.
Okay, this lesson's probably the most
okay,
favorite
right?
lesson we've ever done.
Holy crap. God, that's
Please get enrolled to the yak.
All right,
What are your dreams?
let's go through this first one. First one here. So,
I could use a calculator.
Alyssa, what's A in this first problem?
Ow!
So you gotta do 230 times 10 on
You gotta do it twice.
Hey, put that.
this? Are you sure? Or just do 2300?
Carissa, what's the R on the first problem? After we change it into a decimal? Yep. 0.08. Raven, what's the T on this one?
10.
Yep.
10 what? 10 years.
How do you plug that? No, I'm not. No. I was trying to be funny, but I couldn't think of anything. I tried to give myself a little time by gesturing at the board, and it didn't work.
He's like,
I'll check the board too.
All right, Kel, what'd you get for the first one?
A
14.
versus 5 equals.
8.5.
Nope, James, she messed up. James.
Oh, I got the wrong one.
Yep.
Oh,
10.
okay, there you go. What's it equal?
2,590.71.
And what do my units need to be, Jaden?
Huh?
What should my units be?
What do you mean? I'm confused.
Dollars.
I got it all done. I got it all
What
done.
did it say?
Yeah. What? This is
Oh, I
actually. Wait, what number did you get? I think I wrote it down wrong.
Yeah, that is wrong. It's
Yeah,
it is.
7.1.
Hey, where'd you get 3?
Oh, 7. Okay.
That's what you
7
said the first
there
one.
you go.
230 every month.
That's
Save all those payments for 10 years. And
That's a 7.
so
I fixed
you
it.
do,
Seven
There you go.
point
That's
zero.
you.
And these are dollars.
Yeah.
Why 230 times 10?
All right.
6.7.
So if you haven't yet, start on the second one here.
Well-
It's a little sneaky, so be careful.
2760.
Art.
I could be wrong too.
I just got that.
Can I do this one? I want to do it.
Maybe you'll help.
I volunteer.
I got this.
I want to
Oh,
say.
No.
Dang it.
I want to say
Close enough.
27,000.
You want a what?
I want to say the
I'm not the answer, that's what I got with this.
Monthly interest, how much money will you have
I
after
want to
30
say the
years?
answer. so I feel
27,000.
rich.
What'd you do?
Do 230 times 12, and
Yeah,
then
that's gonna be a
that
big
whatever I
number.
got there times 10.
Did it times
It's
that?
a pretty big
I don't like
Yeah,
times
because
that.
230 every month, so multiply that by a year, and then get that year.
30 years, right?
Times,
But what kind of interest is it?
I don't know if that makes sense.
I don't think that doesn't seem.
230,
I have my own paper.
and that's 1 year. That's 1 year.
I'm just gonna cross out that
So
first
if
thing.
it's 12 a year,
Yeah.
30 years,
Using
you're gonna have to do 30 times 12.
Plus you.
30 every month.
Okay.
Save all those payments for 10 years.
I'm gonna do the
Because you gotta move the decimal left twice. You did once.
What?
Get rid of the
.025.
Yeah, yeah, yeah. Go.
Well, I'll do this one.
Do it down there.
The
Decimal is right there.
6.7.
Looks like it.
Go,
That's a lot of money.
Gotta do it right.
That's what my bank account looks like next year.
Next year.
August or 9/3.
Where?
Mm.
Koki,
Alright.
yeah. Koki, ask a question.
Yeah, I forgot.
You blow it
We
up.
both did.
Yeah, what?
Did I do this right?
Oh, probably.
What's that?
Wow.
Can I get?
On the exit.
Still debating. I don't know if I want to do it.
You do it. It's every month.
I want to like it. I want to like
Yeah.
it.
You look like that for 10.
You look
Mhm.
And
expensive.
then I plugged it in.
Yeah, they are.
There. But this is messed up.
And,
So I got this, and I got that.
or Mercedes
Probably.
E6. that kind of thing.
Let me double check after you.
And I'm just gonna write it down.
Alright, so let's go over this one. Devin, in this problem, what's A?
A and Raven.
Oh, I totally forgot about
360.
the
No, that's the wrong end. That's the wrong end. 12,000.
3 times 12.
I can see you rocking.
And then
Hey, James, what's R?
0 times 10.
No, R.
That's
0.25.
26.
0.025.
There you go.
And you
0.025. And Basin, what's T?
Uh,
I don't know if I did this right.
360.
Mm-hmm. 360. Because remember, this one was sneaky. So it's for 30 years, but it's monthly. You get this insurance monthly. This is another really, really, really good bank that you should really invest in. So if it's monthly, that means you get it 12 times a year. 12 times a year for 30 years. You multiply 30 by 12, and you get the 360. So this one was a little sneaky. You gotta be careful with these sometimes. All right, and Austin, what did you get? How much money is you gonna have?
87,050,804.09.
87 million what?
50,000.
50,000.
I was thinking 500. 50,000 and then
804.09.
804.09. So big I had a hard time writing it. Man, that would be a nice bank.
30 years.
I'd wait 37 years, or I'd wait 30
Don't worry,
years for
you'll get
87
it
million.
I'd wait another 10 years, probably
Yeah.
double that.
Oh, yeah.
I'd wait 60 years for that much
Actually,
money.
solve it for 40
Alright.
years instead of
You
30.
might be dead in 60 years
I don't know. Desmos is probably gonna round that to scientific notation. Hey, I'm not. Actually, I'm 30. I would be. I don't think I'm making it to 90.
Why not?
What? Coco, what's wrong with you? Why would you say that?
You'll make it.
I don't think anyone in my family's ever made it to 90.
We can do 360.
Why, that's not supposed to be.
Why are you
I
laughing?
said that.
God.
Unless you're messed up.
Jeez, that was like a monopoly.
Alright, that's it. Start on your exit ticket if you haven't already, and then I'll put your homework on Google Classroom and Scred on in a second.